Let's learn how to factor the sum or difference of two cubes. For example, x cubed minus y cubed. Notice this will be a binomial. A binomial is the sum or difference of two cubes if these two conditions are satisfied. The main condition is that both terms are cubes. The second condition is just to contrast this to the difference of two squares. The difference of two squares only works for the difference. Notice this works for sum or the difference. So in this case, the signs of the terms could be the same, which would be the sum of two cubes, or the signs of the terms could be different, which would be the difference of the two cubes. Both cases work when it's two cubes. As we learned previously, only the difference works for two squares. A term is a cube if the term can be written as some base raised to the third power. So for example, 3x raised to the third power is a perfect cube. The base is 3x and the exponent is 3. This is not a perfect cube, as there's no parentheses, so the base of the cube is only the x, not including the 3. This would be fine if 3 itself was a perfect cube, but it's not. Here's another example of a perfect cube, 8x cubed. The reason, even though there's no parentheses, is because 8 is a perfect cube itself. Thus, it can be rewritten as 2x as the base raised to the third power. Another example is x to the 12th power. The reason is because this can be rewritten as a base raised to the third power, using the definition of exponents and properties of exponents. Any term that has an exponent that's a multiple of 3 can be written as a perfect cube. However, if the exponent is not a multiple of 3, for example 5, the term cannot be written as a perfect cube. Here's a list of the first few perfect cubes for numbers, and the list goes on forever. It's important to be familiar with these so that you can recognize them. These numbers are all perfect cubes because there exists some base that we can raise to the third power in order to get those numbers. For example, 64 is a perfect cube because 4 cubed equals 64. So how do we factor the sum or difference of two cubes? We use these factoring formulas. The left side is the unfactored form, the right side is the factored form. If you're given something in the format of the left, you can rewrite it into the format of the right. Here's the steps to follow. After checking for the GCF, find the values of a and b. Determine if you're working with a sum or a difference of two cubes. Then plug the values of a and b into the appropriate formula. We have two formulas, one for sum, one for difference. However, you can think of this as a single formula and use the acronym SOAP to help you remember the changing in signs. These formulas are exactly the same as far as the values of a and b. The only difference is the placement of signs. SOAP stands for same, opposite, always positive. The first sign will always be the same as the sign of the unfactored form. The next sign is the opposite of that, and the last sign is always positive. Thus, you can just memorize one formula, then use the acronym to get the other. Let's do an example. First, we must check for the GCF. The GCF is 1, so we can proceed. We're asked to factor a binomial. Remember the factoring flowchart? Once checking for the GCF, then you determine the number of terms in your polynomial. If you're binomial, you check if it's a difference of two squares, difference or sum of two cubes, or neither. What do we have? Since we see that cube, it definitely cannot be two squares. Is it two cubes? Yes. And it's the sum of two cubes since there's a plus in between. Let's follow the steps to find the factorization. A is x and b is 1. a and b are the base of the exponential expression. We're ready to factor using the factoring formula for the sum of two cubes. Now we must substitute the values for a and b. And we have our factorization. With the sum or difference of two cubes formula, typically there is some simplification you need to do afterwards. For example, here negative x times 1 we can simply write as negative x. And 1 squared is just 1. Thus, we have our factorization. We should always check our answer by multiplying, which gives us this, but then we notice terms cancel, thus verifying that our factorization works. Let's do another example. We're asked to factor. As always, we must first check for GCF. In this case, the GCF is 2y. Let's factor that out to get this. Now this polynomial is factored, but it's not completely factored. Next, we must examine how can we factor the polynomial inside the parentheses. Let's factor that in a sidebar. Here's the value for a and b, and we see that yes, this is a difference of two cubes. We can factor using the difference of two cubes factoring formula, and we need to plug in the values for a and b. Be very careful to include parentheses as needed. You must have parentheses here, otherwise only the y would be squared and not the entire value of a. This is the factored form. However, there are some simplifications that we can do. First, we can square the 4y to get 16y squared. Then multiply these terms, and finally square 2. Thus we found the factorization of this binomial. Let's plug it in to return to our original polynomial. Thus we have the factorization of the original polynomial. As always, we should check our answer by multiplying, and we verify that our factorization is correct. We learned how to factor the sum or difference of two cubes.